Okay, can you hear me? Is everything okay? Yeah, thanks for coming. Yes, my name is Marco Casassa Mont. I'm a principal research scientist at HP Labs. I'm going to talk about big data for security as a broad topic, and then focus on some of the R&D work we are doing in labs jointly with the business that with a live demo. So if wireless connectivity allows me, I'll connect back to our data center in Palo Alto to show you how we are doing some of this stuff for real. So this is linked to a research project that is basically, the main topic is how can we help organizations that are collecting a lot of data, in particular security data, to make sense of it, to identify new security threats that are basically unknown at the time of collecting data. So it's not trying to identify threats that are and security issues that are already known, but the ones where there's no signature, no pattern available. So your antiviruses, firewalls, intrusion detection system are unlikely to detect them. So the context where we are positioning it is what is called the kill chain. You may be already familiar with that. It's nothing new. Lockheed Martin came up with the terminology. It's just reflecting a shift in the focus of the attackers. So there are still a lot of attackers that are targeting companies, government, institutions to bring your infrastructure down, I mean, to satisfy their ego or to show something. But more and more, their purpose is driven by money, making money. So they're quite well organized. They do research on the field. They target specific organizations. They're still exploiting vulnerabilities in your infrastructure, but we see more and more attacks that are driven by social engineering. So you receive an email, say click on your Facebook page to see what your friends are doing, or more targeted, like HP, you receiving your HP voice mail, click here to get the details. We are seeing many cases within the organization. You click on that, or similar kind of attacks, malware is silently deployed, and that's where the infiltration starts. So your controls at the boundaries that are, again, firewall, intrusion prevention, intrusion, IPSs, IDSs are basically bypassed. Your machine is infected, and that's where then the criminals, the attackers, are trying to do what they call discovery. So more or less silently, depending on the gravity of their attack. They are exploring your environment, your infrastructure, jumping across different devices, trying to identify the valuable assets. Could be intellectual properties, business plans, all that sort of things. Collecting them, capturing them, and then eventually exfiltrating with a variety of tools. So that's where the range of attacks could range from very, I would say, commercial ones, so pretty much standard, that are still potentially unknown in terms of signature, but can be easily detected, down to the APTs, advanced persistent threats, where they are really targeted, quite often driven by industrial espionage or government attacks. That's where there's some very complex kind of process going on, and it's hard to detect. So we're trying to cover both, but to play the same game and not knowing what the signature is really playing this space. So while the attack is happening, we need to collect the big data, as much data potentially as we can, in a clever way, as I'm going to describe, and detect the issues by analyzing pretty much real-time or near-time this data to find some of those patterns and then push to the remediation. So that's the main, I would say, as far as we have been concerned. We've been talking to many customers, to many institutions. That's what would help them. That's where we've been doing some research, and I'll show you some of the capabilities that we are productizing. The other key issue that we are facing is how you position that. So doing just big data for security in abstraction is nice as a research, but you need to position that within the processes that are in place within organizations. And quite often, at least most of the commercial groups, companies we've been talking to, they got security operations in place. So they got quite complex processes that indeed at the very bottom already collect a lot of data of various types, from structured to unstructured. Then they got this process in place that is involving triage. So you got some early indication that there might be a problem. You have always to understand if it is true positive or false positive, because you got limited resources, as always the case. If the decision is that is really an issue, then usually the process involves collecting more data. You don't want to chop off your CEO's devices or business critical capability. So you really need to get the context and be sure. And then you can the team is carrying on the remediation process. And unfortunately, while you can collect potentially data in real time, the overall remaining part of the process can take days or months. Again, that's the common feedback we are getting from customers. So one of the challenges is, detecting and remediating as fast as you can if you are sure that that is a true positive. So I'll show you a few cases. That's a very hard problem. And I'll show you a few cases where we could do that. And you can also leverage some of the emerging technology like software-defined networks coupled with early detection to close the loop with requiring minimum supervision from personnel. So that's exactly what I just said. Again, the part I'm focusing today is really the detection with big data, but I will provide some more details how we are experimenting with closing the loop, remediation, recovery. So, and by the way, if you have any questions, I don't know, what is the process? We ask at the end?
It's up to you.
Yeah, just ask. Or if something is unclear, just stop. So again, big data could be everything or nothing. We had to really focus on something tangible and realistic. So while we want to consider, I think customers want to consider as many potential types of data as you can, what I'm presenting today is a use case on DNS data, a domain name server. Are you familiar with domain name server?
Is it internal DNS or external?
Both, yeah. So for the people that are familiar with DNS, that's fine. For the people who are not, this is a core infrastructure underpinning the internet. I guess most of you is familiar. And I'll give a brief overview just in case you need it. The taking point here is that it's really, really big data. And provide a few figures we are getting from HP IT, that is the infrastructure, is the organization running all HP infrastructure worldwide. Big data, and is at the same time a gold mine. I mean, just by scratching the surface, you can find so many security attacks, starting from the obvious one, but unknown, because there's no signature, to others that are really quite scary. And unfortunately, I cannot talk. We have been detecting a few of them. I cannot talk because about them, giving details, because are under investigation involving other organizations beyond HP. But I give you some hints of what's going on. The main issue is that this data is hard to collect. So we are talking about potentially billion events in an organization like HP, 100 billions in a medium ISP providers. So how you collect and analyze this data at scale to detect the issues almost in near time. You don't want to detect in 10 days. It's happening now. You have to detect in a matter of minutes or few hours. So that's basically a challenge. Is the same for all types of data. But DNS has got some peculiarity. That's why we choose this one as a starting point. So again, for people not familiar with DNS, I already mentioned is a core infrastructure in the internet. Basically, you go from a logical domain like bbc.co.uk. All devices are talking IP. DNS is doing the matching. Could be doing internally with your infrastructure, DNS server, if it is authoritative, or you have all these bouncing back and forth to relying on external authoritative DNS service. But in a nutshell, all data we're talking about are queries and potential replies. bbc.co.uk, IP address, or nothing. That looks, well, these are the metadata associated to it. Looks simple, but again, you will be surprised how many of those events you may be collecting if you just plug a logo there. We're talking about potential billions per day, 100,000 per second. And again, all this traffic can be generated by critical servers down to potentially your smartphone connected to your enterprise network. So just to give you some figures, I tried to ground a little bit. I've been told that most of you are technical, so I'm trying to provide some real technical details. So we are currently having some pilots. One is, as I mentioned, within HPAT worldwide. So we're talking about 350,000 people on the all continents, 3-4 million devices connected. So if we see, and we deployed our solution across the entire environment. So we have some figures about the traffic. So this is logarithmic scale. But if you see web proxy data, that is usually very noisy and the amount is usually quite high. In HP, we are getting 10,000 of those events per second, so HPAT worldwide. If we're talking about DNS, that is 120,000 events per second. That's much more than any traditional security information event management tools can cope unless you really distribute the solution and spend a lot of money. So to give you another idea, this is the linear scale. So the blue one is DNS data. All the other ones for us are small data. That's another reason why we started with this one, knowing that if we can scale up that level, we can scale with the other types of data. Of course, the analytics, the way you're crunching data to identify security issues depends on the data, so that's another interesting challenge. So another taking point is that, yeah, you may collect all the data. The question is that the right approach? And our conclusion is sometimes it is not, unless you have plenty of money and resources. You need, especially for DNS, with this volume. I forgot to say that in HP, we've got 120,000 events per second, so 16 billion in the average. ISP are 1 or 2 order magnitude bigger of that. So the challenge is what you do with this data. And again, that's true for all the types of data. Our recommendation is be clever on that one. Collect the data that is more likely to contain the footprint of these unknown threats, rather than just passively collecting everything for the sake of it. Again, unless you got quite a lot of resources. And that's exactly what we've been doing. We had to innovate to, in some way, retain just a portion of the data where we believe there is a higher probability to hit the attackers. If we manage to do that, then, again, that's just, again, on DNS, but I would say the comment is true for other types of data. The reward is quite good. You can do analytics at scale, pretty much in near time, or sometimes in real time. You can detect many kind of things. There are the obvious one, attacks on DNS servers. We've been assisting just recently an attack to, was Arcane Electrics, I believe. They actually exploited some of their process vulnerability to basically mismatch, cache poison, mismatch what is the IP address and the domain name. So we were connecting to a domain name, thinking it was a legitimate one, actually was redirected to a bogus IP address, and all that because of lack of controls. So that's something you can detect with clever analytics, actually simple analytics. You can detect denial of service attacks on the coming if you see increase of traffic and some anomalies compared to baselines. But what I'm going to talk today, because it's the one that I can demonstrate and also the most obvious for organization, are attacks that exploit organization infrastructure, DNS infrastructure. So that can range from basically devices that are infected, could be my smartphone, critical server, and once they're infected, they are trying to communicate with command and control. That's the common type of attack. There's somebody out there that gets access, and then once they got root access, it's like sitting in front of the device. They can exfiltrate, they can use your infrastructure to attack, or can bring down your infrastructure. That's the common one, right? But again, the current trend is that even the commercial, if you want, malware, is exploiting techniques called fast flags. So it's this very legitimate technology that is related to load balancing, so changing devices, servers to load balance the traffic. But again, criminals, attackers, are using that to continuously change domain names and IP addresses. So that's changing on the fly. So if you have SIM/SAM tools, security information management tools that are setting rules, looking for specific domain, a specific IP address, well, your rule will be probably valid for a few minutes. After that, the domain is changed, and the IP address will be taken from a pool or compromised machine. So that is very dynamic and is commonly happening right now. Furthermore, attackers have been using random generated domain names. Have you heard about that? DGA, random domain names. So the malware that we are discovering, I'll show you a few cases live today in HP. Basically, they use very simple algorithm that based on the day, they generate random domains like xwkj65z.com, right? Meaningless for people, meaningful for the malware, because it can generate a few thousand of these in a matter of seconds. Try to connect is enough that the criminals out there, that of course know what the domains are going to be, try to register a few of them with the weak registrars is enough that one of those domains is registered and communication happens, and then you got a pipe between the two devices. And again, exfiltration attacks, everything can happen. And one interesting thing we are experiencing right now, unfortunately I cannot go in details because it's very, it's under heavy investigation beyond HP, is DNS tunneling. So using DNS to exfiltrate documents. But I'll tell you what is the principle if you didn't hear it. So a few examples, then I go through some technology, then I'll show you the demo, and I think we are in time. So one is the one I already mentioned. The DNS service is compromised. You think you talk to HP, actually the IP address in the cache is a different one. That is what is called DNS poisoning. We have been seeing a few of them. There are already techniques available like passive DNS, but the point is that having big data and collecting that historically, I mean for months or years, you can easily create a sort of baseline of what you're expecting the IP addresses are. So if you see sudden changes and that mapping, you can detect in a reasonable short period that something wrong is happening. And that is just by analyzing the replies coming from DNS. That is a resolving IP. I forgot to say that actually you can already collect right now queries, DNS queries, if you plug in your DNS service, but that is an impact on performance. Usually you cannot collect replies from your DNS service unless you turn the DNS service in debug mode. That's killing the performance. If you are production environment, you don't really want to do that. So that's another constraint I didn't mention, but many customers, organizations deliberately, they do not turn on the logging in DNS because it will have a negative impact on their environment. So you have to do other things, and I explained that. So that's an example of attack. The other one is related to what we call DGA, dynamically generated algorithm domain names or random generated. So those are, imagine you got your device infected. Those are the types of domain names I was talking about. Devices are generating on the fly, a few thousand in burst. And I must say we are watching them on the going, and every day there's a new variant because it's very easy. And what really matters is that the criminals, attackers out there, can just register a few of them, and when that's done, and if there is an infected device, again, as I mentioned, there's a pipe here, communication, and your device is on. So all the bad things, exfiltration attacks could happen. So this is happening massively. We are getting that in HP, and we have now put in place processes to early detect, and that's what I'm going to show, and close the loop. We have a cybersecurity team, a security operations center. The central one is in Palo Alto. So while talking, while showing the demo, they are currently in their shift analyzing some of the findings. And that is basically what we envisage. Independently from our technology, the sooner you can detect that, the sooner you can inject in your security operations center, the sooner you can remediate and take action. So the other nastier, I mean, I'm going lower level in terms of bad things could happen, is the DNS tunneling. So what you see on the left is your document. Again, you're infected. Some malware is chunking your document in small slices and making those type of queries, appending chunks of your document at the end of a legitimate domain name that, of course, is owned by the attackers. So while we are talking, with these queries, they are exfiltrating chunks of your document. And they are recombining on their servers. So all you see, if you are even having your logs, is a few thousand, maybe, 1,000, 5,000, those queries, DNS queries. What happened actually behind the scenes is that your document, or your IP, whatever, has been exfiltrated out. So again, detecting this is a drop in the ocean. Consider HP, I said 16 billion, those are a few thousand. Consider an ISP, that is even smaller. It's like basically finding a needle in a haystack. So that's some of the challenges. APTs are even worse. Of course, what I talk about here is it leaves a signature. It's unknown most of the time because the domains are generated randomly, but you can detect them because the footprint is reasonably big. But advanced persistent threats are even more difficult because it's not their purpose to be identified. They are there to do industrial espionage, carry on for potentially years. But you can find anomalies on a smaller scale if you're collecting data now on big scale and you start correlating on a long time period. So again, I mentioned before, if you have a lot of money, you can buy a lot of these servers. In HP, for example, we have a retention period of 90 days. So if we were collecting just DNS over 90 days, we would burn for these servers just for the purpose. I mean, it's good to sell the servers, but probably you can use for other purposes than just storing data that maybe you cannot act on. So that was, as I mentioned, one of our sort of constraints. And I think it's a constraint when you deal with big data, you have always to make a trade-off between what you collect, what is useful for the analytics, and how you make reasonable choices. So in our case, again, for talking now about DNS, we had to split up the problem in three parts. There is a collection and storage part, whereby, as I mentioned, we are collecting DNS. We cannot touch the infrastructure, so we have to be creative, and I'll talk about that. And we are actually dropping a lot of the traffic, what we call the whitelisted traffic. So we are reassessing on a daily basis what is good and what is bad. Of course, what is good today can be bad tomorrow, and the way around. So it's a sort of moving target. But at the moment, in HP, we are throwing away 99% of the traffic. With customers where we have less specialized whitelist, we go 85%, between 85 and 90. That is a huge amount of traffic we can throw away. And then we are pipelining in two potential ways. One is the real time, so leveraging all the investment that have been made by organizations on security information management tools. There are many, ArcSight, Splunk, IBM tools, and so on. So you can use rules and traditional real-time techniques. One of the limitations of those tools is that they got limited memory. So let's say at this volume, you can retain in memory 1 day of data. And you can run your analytics on that. But some of the analytics actually are hard to define with rules because, again, domains change, IP address change, so you should refresh your rules every 30 minutes or less. So that's why, in parallel to that, we are pipelining the data to what we call near-time and historical analytics. So here we have no limits. We can store data for months or years, and we can do the analysis in near time, spanning few hours, weeks, or months back. And that's where really you can capture anomalies, threats, variation of behavior. So that's one thing that I'm going to show. The other thing is that when you talk about big data, it may be stating the obvious, but visualization is core. Sometimes, if you're trying to detect the unknown, you have no proper analytics, right? You can guess, you can make your own investigation, but sometimes if you organize the data properly, then a trained person, security expert, can immediately spot anomalies even without having any automated detection. I'll show you a few cases where, yeah, we detect anomaly automatically, but if you see it, you get so much more information than just an alert thrown. So that's where I'm focusing the remaining part of it. I'll give you an idea of a potential architecture to address that. The other interesting part that is, at least in our case, more R&D. Again, I'm part of the labs, so we are not building products. We are building prototypes and pushing them to business units to productize. But one key area we believe will be more and more important in the future is remediation. So it's quite obvious that security operations centers will be bombarded by 1,000 or 100,000 those alerts. So how can you close again the loop in a short period of time if you believe the alerts are really true positive? And we see great potentials with SDN, software-defined networks. So are you familiar with SDN? Yeah, for people who are not, it's basically an emerging, but actually there are already few products there. Technology whereby you detach your infrastructure, network infrastructure from the control. So you can basically change the way information is routed, cut off devices, or introduce additional capabilities just by operating at the software level. And you got a way to, for example, with OpenFlow or similar protocols to instruct, reconfigure your devices, pretty much in a centralized way. So that's exactly a path where we're envisioning. You detect something, you have certainty that that could be a true positive. You may keep people in the loop or not, depending on your degree of certainty. But then you fire off the remediation process that could run playbooks, could send emails around, notify users. Eventually, you have remediation activity. It could be chop off a device, put it in a sort of compartment, and so on. So those are practical things. And we have prototypes in the labs, but I think it's a little bit early stages before productizing them. So moving towards some more architecture and technology, I'll give you two levels of refinement, and then I'll jump to the demo. And if there is any Q&A, I'll take questions. So that's just restating what I said, but with a closer look to the technology. So on the left side here, there are all, that is chopped off, there are all the devices in your organization. And you got all the DNS servers. As I mentioned before, many customers, including HP, do not want any IT tampering with the DNS service for performance reason. Any logging, even for queries, would have an impact on performance, and if you're in a production environment, that's really what you don't want. So what we've been doing is really following, I would say, pretty much obvious path, using packet sniffer. So they've been around for ages, but what we had to do for this high volume is to deploy them in appliances, so high performance servers, and that is already full path. There are other capabilities, but we are basically feeding the packet sniffer with whitelists and blacklists that we are reassessing at the moment on a daily basis, but can be done potentially on every hours or time frame that makes sense. And this is actually getting feedback from what we are discovering. So again, something that is good today, we discover is bad, we refresh our knowledge, our assessment of the world. So what you can, what you will see in the real-time process is get all these tons of packets coming through, DNS packets. We are sniffing them, focusing just on DNS, but could be any other types of data. We are throwing away whatever is in the whitelist. So again, for HP, it's 99% because we tuned with customers. We got 2 pilots with customers. We are in the 85, 90%. So that is thrown away. We're also using known threat intelligence, right? If you know something's bad, you really want to use it. You don't want to rediscover it. So we are labeling whatever is known being bad with what we call the blacklist. And again, that is reassessed on an ongoing basis. And we retain what is blacklisted, and whatever is left over that we call the gray list data. So it's not the white list, not the black list, it's something in the middle. So that's where nobody knows what it is, right? It's not in the intelligence, in the black list, it's not a perceived white list. And we discovered that actually most of the attacks are really in this unknown middle ground, where basically there are signatures, nobody knows what they are. And that's where most of the analytics are useful to really detect that on the fly. So we are pushing the gray list and black list data to the SIEM tools. I'm using ArcSight as an example, but plug in your favorite SIM/SAM tools. That's where you can do the traditional rule-based analytics in a real time with the pros and cons I just mentioned. In parallel, and that's arrow is wrong, we are pushing the same data in this box that is really our big data analytical solution. That's where we can do the near-time historical analysis. So I'm now opening up this box and going down a little bit in the details. And just saying that being HP, we had to try out our dog food. So we tried some of our tools. You may or may not be familiar with Haven framework. Is a Hadoop, autonomy, Vertica, and security products like ArcSight. But basically, when you're dealing with data, again, making a step back, the data you may be collecting can be structured, semi-structured, unstructured. Most of the data I'm talking now about is structured or semi-structured because it's generated by systems. So they are designed by people, by people with very well-defined formats. So you can use basically traditional tools like databases that can scope a scale to store this data and do analytics. So for example, we are using Vertica, that is talking SQL, but underneath is a massively distributed database, columnar, so very fast, and there are similar other products, of course. And we're using ArcSight for real time. Most of the data, as I mentioned before, in particular DNS, is structured, but you may have to complement some of the findings you get with structured data with analysis on structured data. Could be emails, of course, textual information, things generated by people rather than by system. And that's where tools like Autonomy or equivalent can help you to do clever search and find contextual information. So, for example, if I discover that a machine is infected, I may potentially correlate this data with information that has been generated by the person that owns that machine. And maybe there are signs that something, the person is disgruntled, or maybe is hacked, is trying to do something dodgy. So is adding additional context. I'm not showing this one, the human related, because again, is not part of the DNS, but you may expect there will be more and more hybrid approach to big data covering both structured and semi-structured and structured. So I jump to the lower level details and then give you a demo, and conscious of time, we've got 10 minutes. So I'm just restating what I said before, but with more details. So there is the real-time pipeline. So here we are using ArcSight, but again, plug in your SIM/SAM tool. I mentioned that we are capturing with the packet capture the DNS packets. So that was the real time, right? For historical near time, we are basically getting this data. Imagine 16 billion events per day in HP are roughly 200K events per second. So we are temporarily buffering them. That's one thing that you have to cope when you have this big volume. We are using syslog, but other techniques are using storms or distributed event processing. Then we are pre-processing. We need to clean some of the data. There's a lot of dirty packets information there, and we add the metadata. And then we are injecting in a big database, distributed database storage that in this case is Vertica. We found very easy to use SQL database because you can, it's commonly knowledge, it's very easy to access it. You could use other techniques, a solution like Hadoop and other bits, but for us, that scaled well, and I'll show you a few examples. Our added value as a labs was really the analytics on top of it. All that is plumbing, and you can replace the components. But really the differentiation is the knowledge. How you detect out of this data lake, this ocean of data, the security threats that are pretty much unknown. So we had to define security analytics workflows and libraries of anomaly detectors, threat indicators, and visual processing that can be orchestrated, scheduled, and then visualized. Well, the solution is fully web server based, so it can be accessed all over the places with the right security. I mentioned we are managing whitelist and blacklist. But again, our main contribution is an evolving library of threat indicators. Again, attackers are very innovative. If you have a library of threat indicators that works today, maybe works for a few weeks, then they will know that you are observing them, and they will change strategy. We have been noticing that in the 2 years we've been working on that. So this library has to change. Your solution must be flexible enough to plug in, plug out new anomaly detectors pretty much on the fly. So what we detect is visualizing a fancy graphical environment. That is what I'm going to show. But you cannot forget the operators that are, they might still be operating line-based kind of SIM-SAM tools. So we are synthesizing some of the alerts in a synthetic way. They can immediately have a grasp of what it is, and if they need, they can jump back to this big data solution where they can do forensic analysis, get more context, and introspect the information. We noticed in our security operations center, they primarily trust us, and they gave us feedback is 100% true positive. Nevertheless, they keep checking. Of course, they don't want to shut down a critical device just because we are telling you it's bad. So checking is good, but checking is good if you can do that in a very short period of time and efficiently. So that was another requirement. So we have been also exploring many other techniques, but at the moment, like a dupe. But at the moment, as I said, to cope with many of the attacks we've been exploring so far, that's the architecture we've been using. And I said we are consuming threat intelligence, but we're also generating new ones. So we are discovering things in real time or near time nobody knows about. So while we are consuming, we are sharing that. So we are using Threat Central, that is a sharing platform. But again, that's part of the game, right? You consume some threat intelligence that you get from third parties. You produce new one. You share with the community in more or less open way. And again, there are many privacy, of course, and confidentiality issues there. So sanitization is of your data and what you decide to share, not to share, is a common issue for HP and for customers. And again, I already talked about the software-defined network. So I will stop with the presentation here. Hope it makes sense. I'll show you quickly the demo and then allowing a few minutes Q&A. Okay. So hope the wireless works. I didn't check. Let me check if I'm connected. So I have to VPN back to HP intranet. What you see down here, that's the main console I'll go through. But to tell you that everything is real, so I'm connected back to our network. What I'm showing here is our data center in Palo Alto. So data is going back and forth the ocean. So while we are talking, this one is our cluster, vertical cluster, where we are storing all our data collected from HP AT worldwide. So it's happening while talking. And we have OpenStack cluster with 20 vertical nodes. And there's an additional one. So that's just storing data. And we got an additional node here that is not shown, where we do all the analytics. And that's the one I'm connecting to. That's the one with the threat indicators, analytic detector, anomaly detectors, and visuals. So that's the console our colleagues in the Security Operations Center are looking right now. And the last computation, we are computing data based on agreement with them every 2 hours. So the last computation was 8 o'clock. That is roughly okay. Yeah, the next one is due 10:40, so you won't see that. But what basically they get is an immediate snippet of what's happening HPAT worldwide. In this case, based on DNS data, but the plan is to do any other types of data. That's just a panel, a view. So talking today, up to 8 o'clock UTC time, HPAT worldwide, we have been processing 4.5 billion DNS packets, so live. Of which 1.7 billion are queries. Usually there is a factor 2 to 1 between replies and queries, so pretty much the figures are there. We have been keeping up with our filtering. 99.16% has been thrown away based on current and whitelisting. And if you see the leftover, gray list and black list, pretty much is gray listed data, 0.7%, and the leftover is what we already know is bad. So we are using, by the way, tipping point, RepDV, blacklisting, reputation system, but you can use many other, there are many other ones. So if you just consider the remaining almost 1%, almost 120,000 devices across HP have been engaged in the traffic. So the common approach we've been noticing in the past that is, okay, all those devices have been engaged in something bad, let's send to the Security Operations Center, let's make them do investigation. It doesn't scale. imagine an ISP that's got 2, 3 order magnitude that. No way they can cope, would be crying wolf. So again, our main challenge was how you go from these volumes to 10, 50 top priorities, top alerts, a security operations center can really focus on. And that's where the analytics and the various capabilities I talked about are coming. So what you see on the left panel, probably cannot, on the bottom you cannot read that, but those are just 6 examples of analytics we are computing. I had to sanitize all data. These are all real data, but I had to sanitize for privacy reasons. But basically, we got roughly 40 of those analytical modules. Some of them are pretty much obvious. We are detecting blacklist devices, making a lot of blacklists, severe blacklist queries to sites that are known being bad. So if a client is spending more than 50% of their time talking to blacklists, that must be, well, is an indicator that is bad. Or if he's talking to many devices that are known being very, very bad. So you can think about many variants of this one. But that's stating the obvious, is checking the threat intelligence you already have. Other types of analytics are moving towards the unknown. So, for example, we have been feeding our analytics with intelligence we got from FBI. It is, of course, public knowledge, this one, about Zeus, CryptoLocker, family like that are DNS sync called. So that is a trivial analysis we can do, and there's nothing today, but other days you can see it. Basically, device trying to communicate with command and controls that have been sync called. So you're still infected, but the level of gravity is low. But we can detect that. But what is more interesting is really going up and starting to detect the unknown. So what I mentioned, those are just 2 examples of devices that are issuing while talking random generated domain names. Nobody knows what they are. The signature is unknown. But it's happening. There are a few thousand, so a few drop in the ocean. So unfortunately, we got 21 since today in HP IT, and that's what our Security Operations Center is doing. So and we also have experimental threat indicators where we are trying to detect advanced persistent threat, but I cannot show for the confidentiality reasons we said before. So again, going back to the Security Operator Center and the operators, they will see this console. They have two decision points here. Trusting us, so going to the alerts and really having a quick look, understanding what is going on. So I'm trying to do that. So I jump to the alert page, and there might be some delays because we are transferring data back and forth from Palo Alto. Those are all the alerts that we found today, 21. If I click on one of these, I'm just picking one randomly, is now downloading the raw data and providing a rough summary of what happened. So I don't know if it's visible, but in this case, this device, the 130.177, at the burst of these queries at 1 o'clock UTC time, they are all bouncing back. So I forgot to say, I'm showing 2 classes. One that is infected devices trying to communicate with command and control, but the communication is bouncing back because there is no yet registration. Others, so there is a risk, there is infected, but they cannot yet communicate with the command and controls. The others are actually communicating. There is nothing today yet. So if you see this one, that has been dynamically discovered. Those are the random generated domain names. I don't know if they are visible. So a few, how many there are? 105 out of those millions of events we've been collecting so far. So that's what the operators do. They can just quickly check. They say, oh yeah, it is a random generated. Actually, when we can, we're already providing some labeling. So we know this is a configure, so we're just telling them. But I also mentioned that sometimes that's not enough, and you want to have a bigger picture. So forensic people, for example, bypass totally the interface. They go straight to Vertica with their own tools, and they start making all the sort of queries and correlation they want. That's another way you can use these tools. You got an ocean of data, very fast. You make your own query. You get the response. You do all the correlation. Another one that is for less expert is using visualization, trying to pull together the various bits and pieces. And again, we're using connected graphs as an example. And again, it may take forever, so I don't know if it will load. It was before. While it's loading from Palo Alto, what you will see, if you see it, is a connected graph where you see clusters. At the center, there are devices At the edges, there are the blacklist, there are the domain names. It's very slow. I don't know. Let's see what time. Yeah, that's what I was expecting. The bandwidth of Wi-Fi, okay, we have been lucky. So that is an example of what's happening. You see at the center here, and again, I don't know if you can see from the bottom, that's, for example, is an infected device, and those are the domain names that the device is trying to connect, interestingly, all back to Russia. So this one, just visually, is telling you that actually this one is sharing some of the behaviors with others, right? So there are two, but maybe we don't know what the problem is, but definitely they are infected by the same kind of thing. And to wrap up, just to tell you how visualization can be powerful, look at this cluster. It's been around for a while. This is the extreme case. We got all those devices. I don't know if they're visible. I think there are roughly 10 that are sharing exactly the same pattern. Again, this looks like a configure just by having a quick look. But visually, you can pull together so much information that just by going through the analytic finding and textual one is hard to tell. So I have to cut here. There's not much more time, but if you have any questions, please ask.